So what I wanted to do is give you a little bit an overview of where we are at the laboratory. And if you look at the first page here, we get the laser pointer out. What you see is we have this very nice paperweight, a copy of the paperweight. So this was the celebration, also a reminder that we are actually sort of relying on the future of our field, not only on one agency, but actually on two agencies and a university, and they're all making significant contributions. And they all have to be dancing to the same drum with one common goal in the future, namely to establish a world-leading laboratory, or the world-leading laboratory in rare isotope research. So that's the goal. And all of these have to play together, and my role is sort of being the cheerleader, making sure that everything comes together, that the left hand knows what the right hand is doing. So I'm going to tell you a little bit about both NSCL and EFRIP and how it all should come together if everything goes well. Okay, I need to advance things manually. So the first thing is, of course, NSCL operations. I wanted to give you a heads up, and everything looks great. Okay, so this is how we did operation on the coupled cyclotron facility, and as we turned off on the much more complicated so this is the standalone, much more complicated coupled cyclotron facility, we've sort of had availabilities above 90%, which really required an entirely different way of doing business. There are a number of spikes which I wanted to point out. Okay, after we sort of got up here, when we got this setback, and that was two subsequent power outages. The first one, okay, we blew our helium, we had lost power for the cryo compressor, and blew our helium, okay, and then we refilled it when the power came back on, and we got everything up running, and then there was another power outage caused by an external contractor at the power plant, and that basically made us lose our helium reserve, and it took about a week to get back. Fortunately enough, we could find a truck with liquid helium and backfill, but nevertheless, that was the major glitch. After that, we've been really running quite well. This is sort of measured by quarter, and we've been doing actually extremely well until the last quarter. Okay, and the last quarter actually raised an issue which we knew about, but it's one of those risky things. You hope it's going to go well. You play Russian roulette, and you hope that life goes well. What happened is, we know we have a leak in the liner of the K1200, okay, and once in a while it just breaks loose and we have to fix it, and then you go in and you can't weld it. It's a very complicated leak to fix. So what we've done in the past, we've done what physicists do, band-aids, okay, epoxy, scotch tape or whatever, but I mean, fix it temporarily, but it is something which is sort of an issue. So this one took us down quite a bit with all subsequent failure modes which we went into. So the efficiency went down to nearly availability to nearly 90%. But it got me so much worried that we are putting a team together and saying, okay, what are the issues if these band-aid fixes, which we've been living with for the last decade, don't work? Okay, and I can't give you the answer, but this is sort of one of the issues we have to deal with as we want to extend the lifetime of the cyclotrons, which were, well, they're vintage mid-80s, okay, they're aging machines. How we want to extend these lifetimes and get the maximum science out of it. I don't want to say doomsday, but it is something. Life is risky, and sometimes things happen which are not great. Another important thing, and I don't want to bore you with it, but with EFRIP, there are science opportunities for the long-term horizon, but there are also short-term science opportunities. We like to call them the pre-term operations of the laboratory. As you know, we have convinced Michigan State University to build the re-accelerator in past RIA meetings, and we want to equip this re-accelerator. We are reorganizing the laser spectroscopy arena, and then we have a lot of other devices which are either user provided or are in our near term, near meaning the next 3 years or 3 or 4 years, plan to get them online. And some of those dates are sort of target dates when we want to get them, but some of them will be funding limited. But all gray devices are devices under construction or in the concrete planning stages. Okay, so there's a lot of stuff going on beyond building EFRIP, and of course these will give us significant opportunities for research. This is just sort of as a warm-up. Now, user meetings are important and have had actually, if I just look back the last few years, they had a huge impact on how we conduct our business. Okay, and I want to give you just the last few years, and this is a typing error. Should be 2006. Okay, I did this in a hurry. So we were talking at that time about the reconfiguration of the N2 and 3 walls, okay, which were not really effectively utilized. Okay, that was the demise of the 4-pi array. And we were also talking about developing uranium beam capability, at least at modest intensities, to sort of start out. Could we actually separate the fragments, and could we make use of them? And now they've borne in the meantime some very nice fruits. And the users typically, when we discuss these, okay, they helped us set the priorities, and then there was a recommendation by the user community, exemplified by a letter from the chair of the user executive committee to the lab director, who then dutifully reports back to the National Science Foundation and to his boss, the provost, and typically it comes with a need for additional funding. In 2007, we were talking about whether it makes sense to go forward with a re-accelerator, okay, the RIA 3 project, and we just had sort of gotten a green light through a number of nice circumstances, which gave us some good negotiating power with MSU. And at the same time, it was clear when you have a re-accelerator, there's some new science opportunities. So we were vetting those, and then everybody came to the realization, well, if you want to build new equipment, you also have to have the space to put it in. And that was sort of the recommendation that we should look at whether we could get a high bay going. So the meeting was in June and August. Dutifully, I reported back to the provost of the university that we need an architect and really look at the opportunities to build a new high bay area, which by now is up and available for putting equipment in. And in 2008, I mean, we looked at this in some detail. Okay, what are the first instruments we want to have? Again, of course, FSU by that time had an architect, but then in order to get the funding to do so, we got some strong endorsement, including the reconfiguration of the Leavitt area and also the laser arena. And all these things in the meantime have happened. We also had some strong words for the Anderson ATTPC, and both of those are funded NSF MRIs by now. So all these projects are going forward.